This video is going to look at the General Maths external paper from 2023, looking at paper 1 and the multiple choice questions. So, looking at question 1, a linear association with a correlation coefficient of 0.23 is best described as. Now looking down the line, we've got 0.23, that's a positive number, so we can automatically rule out the ones that have negative, and then we're deciding between weak and strong, and 0.23 is going to be weak. Question 2, looking at the time series plot, we're looking to see, is it cyclical, is it seasonal, is it irregular or increasing? Now it's definitely not, doesn't have any cycles to it, doesn't look like it's got any seasonality, doesn't look like it's increasing, and it definitely looks irregular. So C is our answer there. For question 3, we've got a table for our project, and we're told that the critical path is P, R, S, V, and so we want to work out the earliest completion time if it starts at 11 a.m. So being the critical path, that's the ones we're going to add up to get our time. So we've got 38 plus 32 plus 34 plus 26, and so we get 130 as our answer. Now that's 130 minutes, so we can change that to hours and minutes, so obviously that's going to be 2 hours and 10 minutes. So from 11 a.m. if we add the 2 hours we get to 1 p.m, and then add the 10 minutes we get to 1:10 p.m. Looking over here, that is our answer B. Question 4. Athletes were surveyed about their preferred shoe brand XYZ. The results are in the frequency table. We want the percentage of the field athletes, so looking across to field athletes, out of 40, that prefer brand Y. So that is 12 out of 40. So we can do that on our calculator, 12 divided by 40, and that gives us 0.3, which is 30%, and that means our answer is C. Going on to question 5, we have a scatter plot is created to identify the nature of the relationship between two variables, vehicle age and distance travelled, and we have to choose from the statements below which one is correct. So if we've got vehicle age and distance travelled, we'd be putting the age across the bottom, the distance on the vertical. So here we've got the vertical axis would show the vehicle age. No, we've got distance. The horizontal axis would show the vehicle age as the explanatory variable. Yes, that works. The horizontal axis should show the distance travelled as response. No. And the vertical axis should show the distance travelled as the explanatory variable. So that does look like it could be right, but it's not the explanatory, it's the response. So that means our answer for question 5 is B. For question 6, it says 40 fish were released into a new dam that has the capacity to support 10,000. So our 40 is the initial amount. It's predicted to reach its capacity in January 2030, and so we're in 22. If the fish population doubles every year, which sequence rule models the prediction? So we don't need the 10,000, we just want to work out our number of years for that. So if we're going from 2022 to 2030, that's actually going to be, if 2022 is the T1, then 2030 is going to be T9. So 2022, sorry. Because if we've got T1, that means we're going 22, 23, 24, 25, 26, 27, 28, 29, 30. That takes us to T9. So that means that we've got our n equals 9 there. Our r is 2 because we're doubling. And our T1 was 40. So that means our rule, and our other choice that has that is down here, which is D, but that's an arithmetic. So we already can rule those two out because we know it's geometric because it's doubling. So B is our answer there. Question 7. Which statement is always true for a causal relationship between an explanatory variable and a response variable? So one of the variables is a confounding variable. We know that's not always true. The relationship explained by a third variable, also not true if it's causal. There is a positive association between the variables. Now, the key here is that it's always true. So it may not be a positive association, it might be a negative. So that's out. And the response variable is dependent on the explanatory variable. That's true. So if it's causal, it is dependent on the explanatory variable. So D was our answer for question 7. Question 8. We've got P and Q are the critical activities for a project. And so it's saying what are the earliest starting time and latest starting time for activity Q? Now, a little bit of a trick question, I guess, because if Q is a critical activity, then its earliest starting time is also its latest starting time because it's critical. It's the critical path. And we know that it comes after P, so that means our answer A is the one we're looking for because its earliest starting time and latest starting time is 3. Question 9, we've got is determine the 6th term of the arithmetic sequence that begins with 3, 9. So we're multiplying by 3. So you could, if you wanted, just sit and write that. I like to do my calculator and just times by 3. So then I've got my 1, 2. I can then go 3, 4, 5, 6, and I get to 729 as my answer. Oh, no, I've done that as a geometric. Actually, I need to read that carefully. Arithmetic sequence. So always be careful with your wording. I assumed it was multiplying by 3, but no, we're adding 6 each time. So let's try that one again. 3, we'll store that, then add 6. So that gives us our second term, third, fourth, fifth, sixth, and that gives us 33. Always read the questions very carefully. Question 10. We've got an annual sales data in our quarterly indices there. So we've got our data, we've got our quarterly indices, and it's told us by working out the average percentage method using the mean. So that means they would have added up those 4 and divided by 4, and then to get the index done, that number divided by the average. So we want to find the values for X and Y. So here's our little key bit of information there. So because that's a 1, that means that the 160 must have been divided by 160 to get 1. So that means that our average must equal 160. Now if our average equals 160, then our total must equal 160 times 4. So when we do 160 times 4, we get 640. And that means that these 4 being added together would equal 640. So when we do 160 plus our 128 plus our 200, and then do 640, take away that answer, we get 152. So now we're looking at C or D as our answer there. And then we have to work out Y. So now that we've got our 640, and we know that our average is 160, then what we're going to do to get so we've got our X there, to get from the 128 to our seasonal index, we need to divide that by the 160. So we're going to do 128 divided by 160, and we get 0.8 as our answer, which means that it must be C. So that's how we get our answer of C there, because we've got our 152 and our 0.8 from doing 128 divided by 160 gave us a 0.8. Question 11. An annuity with initial 0 balance has $500 deposited at the end of every month. The annuity earns 4.8% interest, compounded monthly, and we want to find at the end of the 4th month. So I'm going to use my calculator again for that one. So my 4.8 I'm going to divide by 12, and then divide by 100, and then I'm going to add 1 to it. So that gives me what I'm multiplying by each time. So I'm going to store the 0, and then I'm going to multiply by 1.004, and then we're going to add 500 each month. So we store the 0, multiply by 1.004, and add 500. So at the end of the 1st month, we've got 500, 2nd, 3rd, 4th, and we get 2012 0.03. So that's closest to 2012. So that gives us our answer of C. Question 12. We've got a reducing balance loan with an initial balance of 6,000 is modelled by this recurrence relation where n is the number of months. The loan balance at the end of 2 months is closest to. So we can put that into our calculator. Doing it like the one before where this is telling us our amount that we're multiplying by and then we're taking away 400. So if I do 0.03 divided by 12 and then add 1 to it, I get 1.0025. And so that's what I'm going to multiply. So a 6,000 I'll enter into there, that's stored. Then I'm going to multiply 1.0025 and I'm taking away 400 each time. So at the end of the first month and then at the end of the second month. So we've got 5229.03. And so that 5229 means we're closest to our answer D there. So question 12 was D. Question 13. We've got 4 athletes and events and we're wanting to pick the bipartite graph that goes with that. So we're looking and we need the E to be joined to L and S. We need the F to only be joined to J. The G has to join to S and the H has to join to J and L. So here we've got E being joined to J and L. So then that one's not right. For B, we've got the E is being joined to L and S, so that's right. The F is being joined to J, so that's right. Our G is being joined to S, but our H is only being joined to J, not to JL, so this one's out. Going on to part C, we've got our E is being joined to E, L and S, so that's right. F is joined to J, so that's right. G is joined to S, and our H is joined to J and L. So C is our answer there for question 13. Question 14. A calculator is used to determine the equation of the least squares line for the plant growth in the data in the table. So you've got a couple of options. You could sub these numbers in to check which ones were closer. Obviously that means you're checking 4 equations. And then you could probably rule out quickly this way by going 6 multiplied by 5.7 and adding 0.6 is not going to give you 12. They're a lot close together, so anywhere they're times by 5.7, that's gone. So we're just choosing between these two where we've got hours and we've got days. And we know the number of days is what we're multiplying and the H is for height. So without even doing any calculations, you could select B there. Obviously you can put these into your calculator in the table. So if you've got your calculator, you can press the data, you can put those values in there, then do second data, 2 variables, L1, L2, calculate, and then when you scroll down, you'll see that for A and B, you've got 0.5658, so that rounds to 0.6, and then you've got I've got a 16 there. I think I actually changed my data numbers there, so I'll have to go back and check those. So I've got, definitely got the wrong data in there, so we need to clear those and pop that data in. So let's get that data in. We've got 6, we've got 15, we've got 20, we've got 24, and we've got 35. For the 6 we have 12, the 15 we've got 14, the 20 we've got 16, the 24 we've got 18, and the 33 we've got 30. And then we'll do our second data, 2 variables, L1, L2. And we scroll down now, we should get to those A and B values, and we can see the 0.614 and we can see the 5.7. And then we just need to determine the D and the H places there. So could actually do that without needing to do the calculations. Question 15. we've got the resale value of a boat shows geometric decay. Determine the resale value 4 years after purchase. So we've got after 2 years, and so we want to go after 4. We could set up a whole equation for that. I'm kind of looking at that going, well, what have we multiplied by to get from 50 to 40,000? And so I can, if I do 40,000 divided by 50,000, I get 0.8. I can check that on the next one. If I do 40,000 times 0.8, I should get 32,000, which I do. So I'm multiplying it by 0.8 each time. So I can times by 0.8 and get the next one, which will be 3, and then times by 0.8 and get 20, and I get 20,000 for 80, which is B. So could use a rule there, or just work that one out, because you only have to go to the 4th year after purchase.